In section 6, I'm going to go over some of the properties of radicals, including how you can multiply them and how you can simplify them. Let's get to it. The product property simply says when you are multiplying two roots, square roots, cube roots, any kind, you can lump the radicands together under one radical, or you can split them up if you need to do that. If you have a product under a radical, you can rewrite it as radical A times radical B. Sometimes we need to simplify a radical. For example, the square root of 50. It's an irrational number, but you would never see this as an answer like on a multiple choice test. We need to simplify it by bringing out perfect squares. So you have to rack your brain on what perfect square, 4, 9, 16, 25, which of those goes into 50? So we don't want to split it into 5 and 10 because 5 and 10, neither of those are perfect squares, but we can split it into 25 times 2. And then what happens is the square root of 25 is a perfect square. It is 5. So it's now on the outside of the radical, and then we still have the 2 that's stuck in there. Now the next problem, you want to think about what could you split it between 18. And hopefully you came up with 9 and 2. So that would be 3 radical 2. And the last one's really easy, in my opinion. 100 is kind of an obvious one as a perfect square. That is 10 when you square root it. And then we still have a radical 2 stuck under there. And by the way, it's just coincidence that all these examples were radical 2. It's not always the case. Let's do 2 more examples, simplifying. So you have to ask yourself what goes into 54. 4, 9, 16, and so on. And it turns out that the number 9 goes into this. This would be 9 times 6. And we still already have a 5 on the outside. So our final answer is going to have a 5 times a 3 on the outside, and 6. And remember, our goal here is to simplify. So we want to go ahead and write 15 radical 6. And sometimes that's how we say that. Instead of 15 times the square root of 6, we just say 15 radical 6. Now, in the next example, let me zoom in on it here a little bit so we can focus on this. This is a cube root, so you're looking for perfect cubes. Now, perfect cubes are the number 8, the number 27, and it gets big really fast. So 4 to the third power is 64. So which of those goes into 54? And the answer is 27. So we've got the third root of 27 times the third root of 2 times the third root of x to the fourth. So this right here would be 3 because 3 to the third power is 27. So we have 3 times the third root of 2. Now we need to talk about this. We can bring out perfect cubes. That's where we have 3 groups of a factor. So this is actually 3 groups of x. 3 x's, 3 groups of 1x. So x to the third is going to simplify to x. But we still have an oddball out here. We have that extra x that's still stuck in the radical. So we're going to have a 3 and an x outside the final answer. And then inside the radical, we're going to have our 2, let me highlight them here for you, our 2 and our x are still stuck in the radical. So we put our 2 and our x in there. There's our final answer, 3 times x times the third root of 2x. Those are a little tricky. You're looking for groups of 3, trios of factors that can come out. So we had one trio, one triplet of factors, x, 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 and it came out of the radical, and it became a simple old x. So here's a few more examples. The square root of 25 is 5. We're talking about the square root here, so you have to ask yourself what squared is a to the fourth when you're focusing on that a to the fourth. And the rules of exponents say the base stays the same and you multiply power, so 2 times 2 makes 4. So we're going to have an a squared, make it out. Another way to think about it is if we had 4 a's, that's 2 groups of 2. So we have 2 on the outside. Now let's talk about the next one. Some students accidentally take the square root of 9. That's not what you do here. We are taking the square root of b to the 9th. So that means how many pairs are there? How many groups of 2 are there? Well, there's 4, but then there's an oddball left behind. Let me repeat that. We had 9 b's under the radical. So how many groups of 2 would there be? 4. So the 4 makes it out, and then we're left with that 9th b factor is still left under the radical. So the final answer would be 5a squared b to the 4th times the square root of b. On this next one, it's another square root problem. So again, you can ask how many groups of 2 go into 7. Well, there's 3 groups of 2, but then there's 1 left behind. So that makes your 7 under the radical. Now, all the y's are going to make it out because there's 4 groups of 2 in 8 and no remainders. And then z is also going to be to the 4th power, but we're going to have that 9th one left under the radical. So the final answer there is x to the 3rd, y to the 4th, z to the 4th times the square root of xz. Now this last one, we're looking for groups of 4. Let me zoom in on this to help out here. 32 is 2 times 2 times 2 times 2. That's 16 times 1 more. Now we're looking for groups of 4. So there's a group of 4 that's going to make it out of the radical. And we're still going to have 1 factor left under the radical. So we had 1 group of 4 make it out. It became a 2 to the 1st on the outside of the radical. And then we had 1 left under it. And we're going to have some a's make it out. So we're talking about a total of 9 factors of a under the radical. So the question is how many groups of 4 does that make? It makes 2 groups with 1 remainder. And then on the next one, we're going to have b make it out. And there are 5 groups of 4 total. So b to the 5th is how we represent that on the outside. And there's no b's left under the radical. So there's the answer. Now let's quickly talk about multiplying radicals. As I mentioned on the first slide today, radical 15 is what you get here. And then you do need to analyze that and ask yourself, does that simplify at all? Does any perfect square go into 15? And the answer is no. Now on the next one, we're going to get the square root of 126 when we multiply that. And then what happens is actually 9 goes into that. We have 9 times 14. So the final answer really needs to be written as 3 radical 14. Now I want to point out, let me zoom in here, 6 is 2 times 3. And then 21 is 3 times 7. So when we lump it all together, we are going to have a pair of 3's under the radical. That's what the 126 has in it. It has a 3 times a 3, which is a 9. So you can spot that before you even start, and then hopefully avoid getting a really big number like 126. So I knew the answer was going to be, these guys are going to come out of the radical and become a 3, and then these 2 things remained under the radical, and 2 times 7 is 14. So that's how I could kind of do that in my head without going to 126. All right, let's take a look at this next question. The square root of 8x to the 3rd times the square root of 6x. So we're going to recognize that this is 4 times 2, and this is 2 times 3. So we have a pair of 2's. Those are going to make it out. And we have a 4. The square root of 4 is 2. So these things all are going to be taken out of the radical, leaving a 3 in the radical. Now we're going to have a total of 4 factors of x. And we're doing the square root, so we divide that in half, and we get x squared on the outside. So the final answer here would be 4x squared times the square root of 3. Now this last problem looks really intimidating, but it's actually pretty easy. We already have some numbers outside, so they're waiting for all these variables to get out of jail. So we have a 6 on the outside just to start out with. Now this is 6 times 2. 12 is 6 times 2, and then 30 is 6 times 5. So the 6's are going to make their way out and cause another 6. And take a look. We've got a 2 and a 5 left in the radical. So we can go ahead and write that as a square root of 10. Now let's take a look at the variables. We have a total of 3 x factors. So one of those will come out. The x squared is going to turn into x, leaving 1 behind. And then we're going to have a total of 4 y's under the radical. So that makes y squared on the outside. So let's go ahead and rewrite that. That's 36 xy squared times the square root of 10x. Okay, so that last slide was probably the hardest one. This actually gets a little simpler again. So when you add or subtract radicals, I want you to remember it's just combining like terms. So you're just combining like terms when you do that. So for example, if you have one radical 3 and you add another, you have 2 radical 3. That is not the square root of 6. It's not the square root of 9. If you do the math here, the square root of 3 is about 1.7. So that would be 2 times 1.7, which is 3.4, which is not the square root of 6. It's not the square root of 9. So the only way you can write the answer is 2 radical 3. 1 radical 3 plus 1 radical 3 is 2 radical 3. Apples plus apples make apples. That's how a lot of teachers like to talk about that. Off to the right here, we see that we have radical 15s. So the answer would be a radical 15, and how many do we have? We had 5, and we add 2 more, that's 7. 7 radical 15. And this last problem down here would be negative 6, and we're talking about cube roots of 2y. It really is that simple. One last thing here, what happens if the radicands are not the same? Well, maybe they're just in disguise and they are the same. So for example, we saw these 2 radicals earlier in this presentation. This is 5 radical 2, and then this is 3 radical 2. So it's time to write the answer. You heard the bell. 2 radical 2 is the answer. Let's look at this next one. We have a 4th root and we have a couple 3rd roots. Well, this is actually 2 3rd root of 3 plus 1 3rd root of 3. That makes 3 3rd root of 3. And then you're going to want to see if there's any perfect 4th roots that go into 192. And I believe it's 16. So we have a 4 on the outside. So that makes for an 8 because 4 times 2, this right here is 2. 4th root of 16 is 2. And then that leaves behind the 4th root of 12. And there is no perfect 4th root that goes into 12, unfortunately. So that's the best you can do. You cannot combine a 3rd root and a 4th root unless you're going to decimal land and using a calculator. But if you want to write the exact answer, there it is. All right, good luck on the assignment.